Hello. Okay, I am very sleepy, but let's start. Questions 103 to 109. Right. So, a graph shows the proportional relationship between the number of test questions the student gets correct X and the student's test score Y. Okay, so they're telling you what X and Y are. Okay. The ordered pair, and they give you an example of one ordered pair. What does the Y coordinate of the ordered pair represent in this relationship? Okay, well, they're telling you X is the number of questions correct, right? And the Y is the score. So if they're saying this is 1 and then this is 5/4, they're saying that one question is 5/4, right? So when I'm looking at this, you just got to find out what it is because they're telling you this outright, right? So they're saying that if I look at this, it's got to be something that has to do with the score. And well, it can't be A because that is talking about the time. It can't be C. I don't know why it's saying the average student can answer 5 questions in 4 minutes. A student who answers 5 questions correctly will earn 4 points. Okay, so that is not what it's saying. It's got to be this B, right? And it's also another thing with the keywords proportional. You don't have to look too into this question, but yeah, just say that, oh, it's 1. They're telling you what one question correct is 1 and 1/4, which is the same as 5/4 points. Okay, and the proportionality says that like with every increase, right, in like the X, there's the same increase in the Y. Okay, but maybe I just yapped too much for that. Okay, 104. Okay, this is statistics. In a survey, so there's like some kind of sampling of 200 total adults. So I'm gonna put that on the bottom. In the town of Waskegon, 45 of them did something they read online. So I'm gonna put this as a fraction. If 25,000 adults, so now this is like the reality, right? The 25,000 adults, that's the total, so that's the bottom. Live in this. Now they're saying which number is the best estimate or like an indicator of the number of adults who read. Okay, so the topic is it's statistics. Okay, so what they'll do in statistics is they'll take samples, right, for some kind of experiment that they perform, because in reality you can't. It's very very difficult to like survey every single person in like a population because it's just too many people. Okay, it's not feasible. So what they'll do is they'll take a sample and hopefully the sample is good, and they'll say, oh, some number of them have a certain property met, and then they'll use it like this, and then there's like probability involved, right? And they're saying that, oh, a good indication of this using the sample, you can say something about the entire population here. Okay, anyways, that's just the higher level details, but to do this problem, you just got to solve this as a proportion. You set this equal, right? The sample fraction is equal to the population fraction, right? And you solve for x. So to solve for x, you just cross multiply, but faster, you just multiply both sides by this. So that means that you do 250,000 times 45 over 200. And then some math tricks. There's 2 zeros on top and 2 zeros on the bottom you can cross out. And then you just got to do this math here, right? Let me see something else. There's a lot more zeros I put here. This is bad. Okay, so it's not 250,000. My comma's off. It's 25,000. Okay, so then that means I cross these two out. So then that means it's just 250 divided by 2. That's 125 times 45. So you just got to do 125 times 45. Okay, and let's just do that. 5 times 5 is 25. 2 times 5 is 10 plus 2 is 12. 5 and then 1, 6, 25. Skip a spot. 4 times 5 is 20. 4 times 2, 8, 10. And then 4 times 1, 4 plus 1 is 5. So then you add this 5, 2, 6, 5. So assuming this proportion holds, then this would be the best indicator of the number of people in that town that read. But if you look at the choices, you don't have that. So then you would say the best estimate would be this. So it's like a further approximation that they're doing. Okay. All right, next. Okay, there's more proportions here. So a hiker plans on hiking 17 miles in 3 days. Which equation describes the relationship between the number of days hiked x and the number of miles traveled y. Well, okay. So they're saying the number of miles traveled is y. So this you might have learned in middle school, right? Constant to proportionality, y is equal to kx, okay? So they're saying that this hiker is planning to do 17 miles in 3 days, okay? That does not, in reality, that does not tell me how much mileage he'll do in each day, right? But this question secretly assumes that it's like a proportional or like an averaged amount, like the same behavior each day. So if you think of it like that, right, then you could think of the y as the output, and that's 17, and that's equal to some constant k. I don't know, it's like a slope. So I'm gonna call this k for now, and x we know. X is the number of days hiked, so it's 3. Okay? And then looking at these choices, I know that this is talking about constant proportionality because it looks like some format. Y is equal to a constant times x. So now if I try to solve this for k, we just divide both sides by 3 and we get that k is equal to 17 over 3. So what does that mean? So assuming that this hiker follows this proportional relationship, then that means that the equation y is equal to 17 over 3 times x should be the equation, which is choice C. All right, next. All right. Carolyn walked 3 miles from her house to the library and then 2.5 miles farther to the grocery store. Okay, so I'm gonna call this C for her house. Then she did some amount. We can call this like, there's 3 miles here. This is to the house to the library is L, and then this is like 2.5 or 2.5 to the grocery store, G. And then returning home by, oh, important, the same route. She walked 1.5 miles before stopping at a friend's house. So that means she's taking the same squiggly path backwards, right? So like something like that, but she makes a pit stop, okay? So she covers only like a little bit of this. So it's 1 2/3, okay? And then they're saying, how many miles did Carolyn have left to walk home? So the picture isn't necessary, but it gives you a nice visual to see what operations you should be using. So to get from her house, C, to G, the total is just going to be 3 plus 2.5, right? Which is 5.5. Okay? That's when she hits G. Then she returns home, and somewhere along that path, it's the same path, she walks that much. So her friend is somewhere in between L and G, so we'll call that F, okay? But you don't need to know the details. You just got to do 5.5 minus 1 2/3, and that should give you the, if F is here, right, then the remaining is here, okay? Just look at the picture and think about it. All right, so then that means that the answer is just going to be this. That's just the remainder amount of walking she has to do. And to do this, you just got to get the common fractions, denominators. So then I could say this is like 3/6, and then the common denominators is going to be 4/6. So this is a little annoying because it's you're subtracting with the numerators, right? So you have to do a borrowing. So I can deduct 1 from here, 4, and then I add 6 here. That's going to be 4 and 9 6. So now 4 and 9 6 I can finally subtract. 9 6 minus 4 6 is 5 6, and 4 minus 1 is 3. So it's going to be 3 and 5 6, which is choice E. 107. There's a lot of fractions here. A child grows 1.25 inches in 1/3 of a year. What would be his yearly growth rate in inches per year? Okay, so that's not bad. Okay, if you think about the right picture. Well, pretend this bar, right, is like, okay, not bar. Let me see this. This bar, that's 1 year. Okay? Well, they're telling you the behavior for 1/3 of this. They're saying that in 1/3 of the year, he grows 1 1/4 inches. So now they're asking, what would it be per year? So that's the entire year. Well, there's 3/3 in 1 year, so that means all I got to do is multiply this by 3. And if you do that, you're going to get 3 3/4, which is choice C. Okay? Next. 108. Okay, arithmetic. All right, you could do this in many ways. Okay, if you're comfortable with your decimals and stuff, but I like reading this as an English story. Okay, this literally means 100th, right? So that's 100th times 3, so that's 300ths. So this is 300ths. This literally means a tenth, and this is 3 times 1/10, so you have 3/10. So you have 300ths and you have minus 3/10. Well, different denominator, so multiply 10 on top and bottom, you get that 3 tenths is the same as 30 hundredths. So you just got to do 3 hundredths minus 30 hundredths, but you clearly don't have enough hundredths, so that's just, it's going to be a negative number. So it's just 30 minus 3, which is 27, but it's going to be negative since you don't have enough. It's going to be this, negative 27 over 100, and that's got to be choice F. You could go through this with the decimals, but it's like more tedious and stuff. All right, but yeah. All right, anyways, 109. Okay, this is also really tedious. A lot more fraction operations and calculations. So what is the value of this? Okay, so you're adding mixed numbers, right? So adding and subtraction, but subtraction is addition, right? So you could do this with PEMDAS and you just go straight like that, all right? But let's use some tricks. So if you view this as all of this as addition, right? Because subtraction is addition, you can take advantage of the commutative property of addition to do a different order, an easier order to make this a fast problem. So watch this. This negative 5 and 1/3 is the same as saying negative 5 plus negative 1/3, right? So that means that I can like collect the wholes, right? Oh, but before I do that, I should change all of this to addition, right? So this is already addition. So this is good. I don't need to change that. But minus minus is the same as plus plus. Okay, great. So when I do that, I'm just going to collect the wholes first. So it's 10 minus 5 plus 2. So 10 minus 5 plus 2, that's going to be 5 plus 2, that's going to be 7. And then now I just got to combine these fractions, okay? But be careful with this negative, right? Because I said negative 5 and 1/3, same thing as negative 5 plus negative 1/3. So what you're doing is 7 plus, right? Sorry, too many colors. You're doing 1/2. Let me use the same color. 1/2. And then this is minus 1/3. And then finally plus 3/4. Okay? Now, to do this, you have to get the common denominators for the 3. And if you go for your times tables, you know a good one is 12. 12ths, right? So then change all of these to 12 and see what you need. 2 times what is 12? 6. So that means the top has got to be 1 times 6 is 6. Times 4 on the bottom, times this, it's going to be minus that, and then 4 times what is, it's going to be 3, so you multiply the top by 3 is this. So you got to just do this math. 6 minus 4 is 2, 2 plus 9 is 11, so that means it's 11/12. And then 11/12 plus 7, it's going to be 7 or 11/12, which is choice B. Okay, so that wasn't that bad today. Not too bad, a lot of calculations, but okay. Hopefully that made sense. Hopefully the beginning made sense, but if not, ask questions, okay? See you.